Alright, welcome back to Moonlight. It's July 15th, about week 15 now. Starting to get into our framing, and also with that we are hitting our airtightness details. Airtightness is one of the 5 principles of passive house, and it is controlling the inward and outward leakage of air within the home.
You wouldn't go up the mountain just in a woolly jumper. You would always wear like a Gore-Tex or a smarter material on the outside, because wind and retaining warmth is better served with more intelligent materials that we have today.
So this is our construction starter strip of our Intello membrane, which controls our vapour internally and also our air tightness. So with this, put the strip up and then we can screw our frame off, and then at a later date when we come in, we tie in a full roll of Intello that goes along this wall, and then we can connect these two, and that way our air tightness is continuous along the walls. This is where our detail continues on through our mid-floor and then up into the second story of the home. This is ready for our mid-floor framing to go on top of and then continue on through the house, and then we can wrap this on the external face of that and then back in under the bottom plate of the second story frame.
Airtightness is commonly misunderstood in New Zealand. People freak out because we've got such a problem with moisture in our buildings, and our buildings are so badly inefficient and unhealthy that we see that as potentially creating more of an issue. But it's misunderstood because this fabric can actually breathe and allows moisture to move through it at the right and appropriate rates.
If you think about it, in winter, it's warm inside, cold outside, warm moist air, and that's trying to go through your wall and escape and go outside. Hits the cold, and there's a diffusion point, like a dew point, where your insulation's just copying all of that vapour. So over time it'll just deteriorate. You know, it's like a puffer jacket. If it gets wet, it's not going to work. Standard glass, like wall pink bat fiberglass insulation, cannot handle vapour diffusion, and it decreases its performance dramatically. And as everyone knows, you've seen it get, most builders say would have seen it get wet, it just won't work. So it all looks nice and dry when you build these houses that aren't airtight or have a vapour control continuous throughout the whole structure. But after 10 years, that insulation's probably not working very well and has had vapour travelling through it both seasons. So in the summer, when it's warm outside and it's cooler inside and that's coming in, you get that same dew point problem. Now we can use smart membranes, keep our houses airtight, and as you've built the structure, as it's drying out, it still allows the vapour to escape back into the house and then be mechanically ventilated, but it stops any vapour getting into the wall cavity. It's week 16 here at Moonlight. We've got the mid-floor down now. So we thought we'd just show you guys how the mid-floor airtightness detail has been done on this job. So as you would have seen earlier, the airtightness membrane we have that goes from the internal surface on our bottom story, comes up and then folds in and comes back out to the external surface and around this mid-floor, and then we're bringing it back into the internal surface again, and that'll fold up the framing line like this, and that's where our Intello Plus will come down and overlap that, and that way we fully encompass that mid-floor and keep it airtight continuously throughout the whole structure. This is just a side on. This whole thing will come up and be fully taped and airtight. Looking forward to having this one all tidied up and finished. It's quite a niggly wee detail to work in with when you've got quite like rough construction going down. To summarise our wall structure, we've got a passive house principle of thermal bridge free construction. So with our rigid air barrier, we have our 10mm polystyrene that thermally breaks temperature in here to externally, and that continues down and connects to our insulation on our slab. Here at Moonlight, this is the product we're using for our rigid air barrier. This panel is designed to be used with steel frame houses, which is a highly conductive material. So to get around that, they go, oh, okay, we'll put 10mm poly on the back of this. I've been seeing it used in the States on timber framed houses, so I wanted to use it here. And this way we get a continuous thermal break over our framing all the way around the whole building envelope, and then I can tie that down into my foundation, which is insulated, and continue that all the way up to the roof. With our rigid air barrier, we can achieve all the bracing requirements for the frames, catering for shear loads from wind and earthquakes. So we have no dwangs or nogs horizontally in this wall, and that's so we can get more insulation throughout that's continuous in this wall. And then we're controlling our internal vapour by putting our Intello membrane on. So we have no moisture trying to escape through our wall cavity and become stuck in here and create a point of moisture, which would then decrease the performance and also create mould in this wall cavity. It's week 20, and today we're lifting in all our structural steel that forms all our overhangs. Last Monday we lifted the steel in with the crane, and now we have been doing our second story framing and getting ready for our roof framing to start next week. Here we're back up on the mid-floor, the framing's going up, and we're taking another look at our airtightness and vapour control layer. What you might notice is how previously we had the Intello vapour control below, and then now we have the Extasana. And the reason we're using this is kind of a bit of a learning for me, is the Intello has a UV exposure of 2-3 weeks, whereas the Extasana has a exposure of 6 months. So this is a better product to use when you know you might not be getting your roof on very fast. Luckily we had the mid-floor on in 3 weeks, so I'm not too worried about that stuff down there, but just to be safer, we're using the Extasana here. So we might look to do that as well with our windows, depending on when we wrap them for the air tightness, depending on the UV exposure. So something to think about for anyone else out there. Here we're looking at our structural steel and talk about it being like a necessary evil. Originally in the design we had these beams with this detail coming into the mid-floor and into that conditioned space. So, you know, it's quite a large conductive material coming into our structure. So working with the engineer, we're able to change it to these point bridges. These two beams here reduced to these plates, and then they're welded onto a post that goes up and takes the load of a beam above. And so we've just encompassed that, isolated the steel beam. Now we don't need to worry about that steel post internally condensating and moisture building up and affecting the timber and creating mold. Now we can get an idea of the roof structure. So we're going to have trusses coming out to here, because from here back the living space is going to have a flat ceiling, and then through here in the living kitchen area we'll have a pitch ceiling. Looking throughout, you'll be seeing some steel beams coming into our building envelope, but what we're doing is we will, again, this is going to be in a soffit space, so we can isolate that steel and prevent as much of that thermal bridging. And also that beam is going to be above our conditioned space, so it's above our airtightness and vapor control layer. It's October 14th at our moonlight build. The roof's about to go on, and we're just going to walk you around and show you some of the critical details we have. This is a very important detail, I feel, in New Zealand, and a way we should be doing our roof detail more often. Here in New Zealand there was the leaky building crisis not long ago, or a decade ago, and a big thing from that is we stopped direct fixing our weatherboards on our cladding, and to provide a cavity for airflow to ventilate the space between our cavity and our structure. So why not do this on the roof? We protect our membrane, so moisture on the underside of the roofing iron is allowed to dry, has all of this space for airflow. It protects our membrane, so it's going to last a long time, and it also regulates the temperature, so it's going to last a long time. We have our 20mm cavity batten fixed over top of our ProClimber Mento 3000 membrane. This is a roofing membrane that's permeable. It prevents the moisture travelling through, but allows drying from the underside of it, from the structure, and moisture to travel out and then dry in this cavity. The benefit is our roofing iron is only going to get fixed through this timber and not out the other side. So we're preventing, holes going through this membrane on every purlin throughout the whole roof. Our roofing iron is doing its job. It's the rain protection layer. It's stopping the rain coming in. Our membrane is protected and is able to do its job by moisture being able to flow in this cavity and this not be exposed to condensation on the underside of the iron, and the membrane will last for a long time. It's often now you're seeing re-roof jobs because of how compromised this material is, and the roof's not having any room for ventilation, and then the insulation's failing and all kinds of problems. So, least favourite part of the design, steel, and its conductivity. Favourite part of the design, overhangs and the steel's forming those overhangs. So what we have to think about with this is we know steel is extremely conductive, and we have some members like this raking rafter beam through here, and that goes from the outside inside. It's not going to be in a conditioned space because in tallow, and then we have another layer of insulation there, so our airtightness vapor barrier, another layer of insulation, but it's still coming from the outside in. This beam is offset, so it's not right on the edge of the building line, but as you can see, we've got the steel through here close to our external surface. So what does that do? It takes away space for insulation, and it's also conductive, so we need to thermally break it, just like thermally broken details with our foundation and keeping that continuous. As you saw earlier, This whole thing is covered in XPS foam, and we're isolating the steel from the temperature fluctuations, and we want to keep that just a nice even temperature. We want to protect it from condensating and a dew point. So by doing that, you'll see on the outside we've completely encompassed that in polystyrene and timber where we've needed fixing. On a normal house, you know, you have these steel members, it's extremely cold on the outside, you've got heating your living space on the inside. You know, the heat's trying to escape, hitting that cold temperature, boom, dew point, all the water dumps out of the air from the inside air, and then you've just got cold, damp surfaces around the steel because it's a conductive element, and what's all around steel? Timber, and then you start getting mould and mould issues and rot issues and the like. So we just look at this air tightness detail again. I guess the theme is, you know, this is all continuous, where we've got our vapor and air tightness membrane here that we're using. You've seen that wrap all the way around the mid-floor. It's going to come up on our wall. Then we've got our Intello air tightness and vapor control layer, and that's going to go up our walls, up our roof, up our ceiling, you know, connect to all the walls, connect to our windows, connects downstairs into that ground level. You know, so the theme again being continuous. To recap what we've gone over, you would have seen our continuous thermal break in a rigid air barrier that is connected to our foundation, and then it comes up our walls all the way up to the roof. We've isolated those steel members and we are thermally breaking those everywhere. And how, if you'll notice the trend as we're building, the importance of all of these things being continuous and connecting all the way down to that foundation, running all the way up those weather tightness membranes, and now connecting all the way on the outside, and our air tightness membrane and those junctions that we can now connect, you know, we're framed over and around them, and those are all going to connect. Next episode, windows and insulation. We're going to be using some pretty exciting systems, so you'll have to tune in and watch the next one.